all of you. So I will be taking you to the Himalayas, what we have touched upon by some other colleagues in the morning. So this is very important for the Indian subcontinent because of the water resource. It's called as the third pole or the water tower of Asia. So all the perennial rivers in the Himalayan region depend upon this. So there are a lot of studies carried out in the Tibetan side by China and the Nepal side, and also Hindu Kush regions. A lot of work has been done, but on the Indian side, very few studies are available, and that we are started doing this type of work in this region, because all the Ganges, Brahmaputra, and all the river system depend upon this. So as you know that the ice caps and glaciers among the freshwaters is 68% of the freshwater is contributed by them, and especially during the monsoon failure seasons, we are all the Indian subcontinent depend upon this Himalayan meltwaters. And as we know that we are discussing about the climate change, it is a natural process also because Himalaya is tectonically active, and changes in the sun and the changes in the cryosphere is a very important, and also the greenhouse gas that we have been discussing in the past 1.5 days. And this is a famous curve. You know that the warmest years are even now the 2014 is El Nino year, so we are facing a lot of monsoon failure, so we are depending upon the snow melt. So these are the facts that you know that the temperature is rising and the intensity of monsoon and the period of monsoon is increasing and the temperature is increasing and mean sea level is rising. That is what we are hearing. And the El Nino events are also increasing in these years. So that is the region that is decrease in the river flows after the glacial recedes, and then the floods and gulfs. Morning that Nepal, he is talking about the gulf. That is the sea level rise, but actually our Himalayas are not contributing that because it is around 2000 kilometers from the land. And then the crop yield and the pattern of crops are changing in the Himalayan region as well as the Gangetic plain. So the vulnerability of the Indian subcontinent to the impact of changing climate is of vital importance for us to understand the hydrology and water resource and agricultural economy. And this is also the rooftop of the world, the Himalayas we can call it, and as I told you, it's a lot of water stores after the polar. The fastest warming in the Himalayan causing the fastest melting of glaciers. The major river system Brahmaputra and Ganges and Indus originating from the Himalayas, and it's vulnerable to the climate change. And the global warming and its impact on hydrological cycle and nature of the hydrological events, it poses an additional threat to the Himalayan regions. So this is the major river systems that if you see that one, the Indus, Ganges and Brahmaputra, which is all the subcontinent is depending upon that, and we are around in the Indian side around 10,000 glaciers are there, but actually we are studying only 10 glaciers have been studied so far in detail in this region. But the total glaciated area is 22,000, around 23,000 kilometers square. So it's having a Himalaya is a very large system. As we are talking about, the elevations are changing in these regions. Each one has its own microclimatic conditions. If you see that eastern Himalayas, 80% of the mass balance, that is the amount of snowfall converted into the ice and storing as the glacier, is contributed by the monsoonal precipitation in the eastern Himalayas, that is Asian and Indian monsoon contribute that, whereas in the central Himalayas, where the Ganga is originating, monsoonal precipitates and the westerly disturbance contribute 50% each. Whereas in the western Himalayas, in the Jammu and Kashmir and towards the Pakistan side, it is largely controlled by the ventral accumulation because high altitude, high latitude westerly disturbance contribute 80% of the influx to the ventral precipitation. And thus the upper reaches of the greater Himalayan river systems are largely replenished by glacier and snow melt and from direct precipitation, that is the monsoonal precipitation summer and the accumulation and melt of snow and ice cover in the Himalayas critically influence the hydrological systems. The climate change is expected to change these phenomena with a great impact on snow cover, glaciers, as well as spatial and temporal distribution of water resource. And if you see that Hindu Kush Himalayan system So the critical, the most vulnerable part are the Indus, Ganges and Brahmaputra. Even though the glaciated area is high and the glacial percentage is high, but they are vulnerable to the rise in temperature. Added to that, the 3 new projects, Yarlung Zangpo in Brahmaputra was listed to be an energy development plan by the Chinese government, and they are going to develop 500-meter dam in this region, the Tibetan autonomous regions. It's going to affect the biggest river system, the Ganges Brahmaputra in this region. And the recent study in the Nature as source of the Indus Karakoram Himalaya contribute to the sea level rise 1% of the sea level rise in the world. Overall, the negative mass balance of the glacier on this region it's not a positive, it's negative. That's again a very intruding factor. For the mountain catchment, the Indus Ganges basin, the glacier imbalance contribute 3% and about 2% respectively to the annual river discharge. So, and up to 10% in the upper Indus Ganges. So, Indus is having a 10% which is going from India to Bangladesh. There is a dispute between the 2 countries in this region. So, if you see this graph, you will find that the blue one is the positive mass balance and all the red and the yellow is a negative mass balance. Whatever side in the Indian side is showing the negative mass balance, that is why the glaciers are receding, whereas in the Hindu Kush region that is a positive in these regions. So, this is the world glaciers showing the imbalance in these regions, and the Chota Shigri glacier, which is has been monitored intensively with the Hindu in this region, is monitored by us in the Western Himalayas. This is the glacier, longest glacier available in the Indian side, where the mass balance is available, and that is the Karakoram is gaining the mass, whereas the Indian side, Himalayan side, is losing the mass in this region. So that is a very that is going to affect the water resource in these river systems. If you see the latest publications in that one, that also supports the facts that the Karakoram region is having the positive mass balance, and the remaining, that is based on the data of 30 to 40s precipitation data, temperature. All these central Himalaya, eastern Himalaya and the western Himalayas are showing that negative mass balance, and it is going to having a larger impact on the water resource. So this variation in the mass balance also, if you see that negative in these regions, highly negative. The recent study by us on the Chota Shigri glacier in the western Himalayas shows that the negative mass balance from 1990s, before that it was stable. From 1990, that is the negative mass balance is approached in this region. So the worldwide glacier mass balance in general showing the negative mass balance, and the sea level rise is increasing. So the recent studies are also the temperature. If you see the western Himalayas, that shows that the temperature is increasing and the precipitation is decreasing in the western Himalayan regions, and also the various glaciers are also showing that snowfall is reducing in these different parts of this basin. So this is by different rivers studied in that region, which also indicates that there is a lot of problem with the water discharge. There is a decreasing in the water discharge in this Ravi, Beas and Satluj and Chenab rivers, which is ultimately entering into the Pakistan from the Indian side. So the effects of the global warming on the river discharge, there is a short term increase in average and flood discharge, and long term effect reduce the average discharge, increase in extreme flood events, and reduction average annual discharge in northwestern Himalayas. That is a very important factor that we have to keep, and how to cope up with this, adapting to the reduction in the water discharge in future. So this is the major glacier which is contributing the Ganges system, and also which is very intricately linked with the culture of the Indian civilization. Ganges river system is there. It's a holy system, and people take it as a holy river, and this is also a lot of problem. In the last IPCC report, they show that this is going to vanish in 2040. That is the, and here also a lot of studies to find out the impact of the rainfall and discharge in these regions. But actually, if there is a rainfall, there is this actually, even though it is in the western Himalayas, central Himalayas, it is a rain shadow region. That's why the precipitation and the discharge is not having a direct relationship with each other, whereas that it is mainly driven by the temperature. Wherever the temperature is increasing, the discharge is also increasing in the Ganges river basin. The monsoon is having a lesser impact, and the temperature is having the more impact in these regions. So this is another study which shows that how these Indian Himalayan systems, one is the alpine system, one is the Himalayan catchment and the cold arid regions in these regions, how this temperature and the precipitation contribute to that, whereas in the Himalayan catchment we get the enough of the precipitation if it is there other than this Ganges, there is melt as well as the precipitation contribute, whereas in the alpine and the cold arid regions the temperature and the snowfall is going to contribute in that one. If there is since already the studies are showing that there is a lesser snowfall, that is going to impact the discharge in this region. And also if you see that one, only some of the rivers, if you see the Chandra river and all, only during the ablation period maximum discharge is there, and that is the reason why we get the perenniality in this region. But if there is a snowfall reduction, then this perenniality will be affected in this region. So this is the investigation that we have been doing it for the past 12 years in this region. So this is actually the glaciological method we use to study this glacier by putting the stakes and find out the mass balance. And this is the study that we have been, this is publicly available in the World Glacier Monitoring Service database. That is the only glacier available from the Indian side, is that for 10 years is from this glacier. The annual mass balance since this 2002 is the glaciological method based taken pit. Longest mass balance data available, only 4 positive mass balance but just occurred in the last 11 years. The mean annual mass loss is 0.59 meter water equivalent from 2002 to 2013 in this glacier, which is an implication that there is a loss of mass occurring in this glacier. And we also try to build up to understand the impact of climate change by the geodetic method, and from the degree day model we use it. And there's a slightly positive balance occurred in between this region 1990 to 2000, and after that it is a negative mass balance in these regions. So this is generally people adopt to find out the area accumulation ratio and ELA method, which is going to tell about the positive mass balance and negative balance over the last 1 decade or so in these regions. So AR decreases with increasing elevation, that means the negative mass balance. So whenever there is a negative mass balance, if you see that overall there is, even though some area is positive, remaining areas are negative, which indicates that there is a loss of mass taking place in this glacier system. So this is the mean altitude mass balance, which shows that ELA is around 4000 meters. So only thing is that above 4000 meter we don't have the monitoring stations. Most of the stations are below 4000. That is another important factor that we have to keep in mind, to use the satellite and narrator to find out the local meteorological conditions where the data are not available. So there are also Indian systems. We have the debris problem, which is going to affect the energy balance of this glacier. We have to take into consideration when you do the energy mass balance in this region. So this is how we do the field survey in this region. So we also try to estimate the velocity of the ice mass and the thickness of the glacier. This is the snout of this glacier and the discharge stations we have in the glacier region. And there is a ablation period, you get the maximum discharge in these regions, and there is a link between the discharge and the snow melt. That is what's shown in this figure. And this is, we also do the lot of monitoring for every half an hour in these regions to understand the hydrological balance in this region. So if you see that one, that is mainly the temperature driven. Only at a few locations wherever the cloud cover is there, that time you will not find the relationship. Otherwise you will find the temperature and discharge is having a direct relationship in this region. So this is another one we try to understand that how this energy balanced affecting the discharge in this region. So if you see that one, the discharge follows the air temperature with time lag throughout the melt seasons. However, it is significantly affect the changes in the albedo on the glacier. After heavy snowfall events as in the 2012, the discharge drastically reduces in spite of some rise in the air temperature. However, in September 2013, The snowfall was light and sporadic, so much so that discharge remained appreciable until the close of the measurements of the early October. So the precipitation occurs both as the solid and the liquid precipitation in this region. So that is having a direct relationship with the affect the albedo. Wherever the albedo, the cloud cover is there, the melting is reduced, and then the discharge is also reduced in this region. So this is the direct. We also tried to find out the weathering and the leaching. From this, we try to estimate from the snow the ions which is leaches out is also directly tell the accumulation rates in this snow. Also, we use the geochemical traces also in our system to find out the weathering as well as the accumulation of the snow, which is directly going to tell about the amount of water is going to discharge. And also, each glacier is behaving differently because of the availability of the lithology and the influence of monsoon in this region. So we also now we are using isotope studies to delineate the melting from the ice, snow, and the groundwater in this region, because this study is very important, so that in future we can say that whether the ice is contributing or snowmelt is contributing. If the glacier is contributing, that means that you have to worry about that one, because snowmelt can contribute to the perenniality, not the glacier melt. So the various to quantify the contribution of various hydrological component to the base flow and surface runoff and the river discharge. So we are using the isotope studies to find out the base flow, which is very important for the groundwater recharge in this region. So that is the study we have been doing it, and the meltwater is very important in order to understand the perenniality and the availability and the water sharing between the two countries in this region. That's what we are doing this study, which is directly linked to the agricultural productivity and stakeholders in these regions. So this is what I want to share with you, because time is out in this region.
Thanks for that talk. I want to start out with a question. Have you looked at the impact of changes to glacial albedo? You know, there's this dark snow project that's looking at this impact in Greenland because of fires, and in the Indian area there's a lot of incomplete burnt hydrocarbons. Has that impacted the albedo of the Himalayas?
Yeah, there is a report from UNDP that Ramanathan has reported that one, but that is only on a short term 1 week study that he concluded that. But as such, we don't have any long term study on this carbon chute and the black carbon.
Maybe that's your next study.
Yeah, maybe if there is something is there, I can study that one. Yeah.
Okay, thanks.
Yeah. Yeah, she's.
All right, thanks. I just have a quick question out of curiosity. How different it is the isotope composition of that of the meteoric water in that region compared to V-SMO?
See, if there is fresh snow, you will be getting the O16 more in that region. If it is with the already become ice and it is cut off from the atmosphere, we get O18 in that one. So the ratios between these two will tell us which is melting and contributing to the meltwater. And we also use the geochemical traces. If it is from the Indian monsoon, we get from the sea spray we get the chloride. Otherwise, if it is from the westerlies which is come from Mediterranean, the chloride is less.
Okay, any other question? No? Okay, so thank you very much, Dr. Ramanathan.
Okay.